Alright, it's day 380 off the grid, and I've got my shit together now with this camping solar power setup. It's pretty much complete, although I haven't put the case back on because I just wanted to show you a few things that I've done on the inside of this unit of the Kingdom Fly portable solar power station, you know. Right, anyway, so let's show that first, eh? Okay, I made a few mods. I've retasked what was the solar input socket to be the battery connection, okay? And I was able to do that because this is a 2-pin what's called a microphone connector. They originally were used a couple microphones, and the 4-pin ones are still used with 2-way radio mics sometimes. But these are often used for DC connections where you want a good mechanical sort of connection, and they do handle a bit of current. You can safely put 10 amps through one of these. Well, 10 amps at 12 volts, 120 watts, and I'm never going to want that put through here, so this is ideal. It was already on the front panel, no new holes drilled. There we go. So now the solar. Well, that's the battery. As you can see, it's this Retar 40 amp hour AGM battery. It came with these nice little boots that sit over top there. They kind of just sit there, but they, held there by the wires. I'll keep those connections nice, and I don't have to disconnect them. You see, I can just unplug it here and the wire can stay with the battery, so it's very convenient. No big crocodile clips or any of that kind of rubbish. It's all good to go. Okay, right, the solar. Okay, inside here is the solar board, and I traced the fault to this board. In fact, I pretty much know exactly where the fault is. It's either in this MOSFET here, which is the actual switching MOSFET, or it may be the diode MOSFET, one of the two, or it's in this thing here, which kind of looks like it's lost its magic smoke. I think that may be a diode. It looks like a diode. I don't know why it's there. It could be a Zener to just a clamping diode, or it could be a reverse polarity protection diode or something like that, but the fault is totally in there, and when I've got the time I'll probably take this board out and try and fix that. I do not have the time at the moment, but I've made a couple of other mods which were necessary, in my view, whether I fix that board or not. And what they were is that these DC sockets on the front here, all of them were connected through this board through the load output, which is the bottom connector down the bottom. The bottom connector down the bottom, you know what I mean? The bottom connector, this one here. And this has load control on this board. It's basically just a charge controller, a cheap charge controller. It's got a few extra functions like this ribbon cable which runs the LEDs and stuff, but it's basically just a simple PWM charge controller, bare bones. And its load controller will, I'm presuming, shut these 12 volt ports down when the voltage of your battery gets too low. And it'll also act as an overload protection, an electronic fuse. And this is a pain in the ass when you want to use something which draws high impulse currents, like this airbed pump, which is one of the essential accessories we need camping. I don't know what the Vikings would have done about these and airbeds, but we've got the airbeds, so we're going to use them. Of course, we all know that the Vikings used the latest technologies they could get their hands on that were useful to them. I don't think they would have really used smartphones. Right, anyway, so I've rewired the two inputs on this side, these two here, and what I've done with them is the positive is common, and that goes through the main power switch to the battery, but I've interrupted the negative wire here. You can see I've capped it off in case I ever want to reconnect it, and I've run it instead through this fuse, which is a 10 amp fuse, and it's connected to the negative of the battery terminal right down in there directly. So it's fused at 10 amps. I know it's in the negative line and that's bad practice, but it's the easiest way to do it here, and since this is an isolated system, who gives a fuck? This fuse, I probably would have wanted something a little bit lower, but I didn't have one. But this is a really cheap, shitty 10 amp blade fuse, so I'll be surprised if it handles more than 8 amps. I mean, I don't know how much this pump pulls. I shouldn't really measure it, but it can't be much more than 5. So essentially these two terminals then, apart from a fuse and a switch, are wired directly to the battery. So therefore I can also use them for a solar input, which is exactly what I'm doing here with this little Sunsay. I've used this before in the bee shed until I got the bigger charge controllers that I've got in there now, and one that preceded them, that large sticker with the LCD display. But this always treated my AGM batteries in there very kindly. It's a 12 volt controller, which is really handy in this situation because you might end up plugging the solar panel in before you plug the battery in, and that's okay because it only works at 12 volts. Whereas so you do that with a 12 and 24 volt charge controller, it may get the battery setting wrong. That's why you always connect the battery first usually. It's good practice. But anyway, so I've just made up this lead here, just got this tail. I used this tail because I wanted to go into a wire that was slightly heavier so it would make good connection with these rather meaty screw terminals for such a small little charge controller. And that just plugs in there. I could plug it in there. In reality, I could actually plug it into these two as well because current can backfeed through the load controller circuit, because of course a MOSFET backwards is basically a diode. So in fact I can actually plug it into any of these inputs, but it's better to plug it into the direct ones because then the charge controller of course gets a far more accurate reading of the battery voltage. Of course, if we went down that path totally, it would be better to connect the charge controller directly to the battery terminals, but that would create some messy wiring and we're not going there. So charge controller, I made this super long lead. I was umming and ahhing about how long to make this lead, you know, cable resistance and all that kind of carry on. And I get really fussy about cutting long lengths of cable short in case one day I need that kind of length of cable. I know sometimes it's a self-defeating habit, what's the word? You know, OCD, I guess. But this solar panel here can put out a maximum current of what? Oh, current at maximum power point is 1.12 amps. Oh, short circuit current 1.2 amps. And in my general experience with solar panels, they really kick out anywhere near that maximum current because the only time they'll ever do that is when you've got a real sunny day and a really discharged battery. So most of the time it's going to be putting out 300, 400 milliamps, maybe 600 or 700, and I don't think the drop in that cable will be a problem. But moreover, having a longer cable gives me more of a chance of putting the solar panel where the sun is, at a camp where there's trees and things. So the ability to be able to put the panel where you want it far outweighs any kind of power wastage you might get in the cable. Not even worth considering. So that's fine. Nice long cable. It's permanently attached to the charge controller. So I just wind up the charge controller as part of the cable. It's good that it's a nice little one. Of course, one day I might get this going when I can be bothered, get the internal one going, but then I've got to figure out what I might do. I might just dedicate one of these to the solar input because really, that's overkill. That's overkill for the solar input. It's good for it's good for the battery. It's just enough. So finally, we've got to get onto this before this gets into a major, wickedly long rant. The mains. So this year we've got a slight improvement to the lighting rig because last year I just used double adapters and just bunged all the lights into the outlet on the power buddy we used last year. But the problem with that is you could only control individual lights by pulling out plugs, and although the argument was it was a minimalist thing while camping, it was just a pain in the ass. So this year I've gone one better. I've got this ancient Carlton really heavy duty steel case made in New Zealand, individually switched power board. You know, this is super quality. It's even got a 10 amp circuit breaker the same as what you'd have on a DB board in a house installed in it. And I did open it up because I heard a few rattles in there, and I just wanted to check before I applied power to it. And it was just some little bits of solder that wouldn't really affected anything. But man, the wiring inside, I should have made a video of it. The copper bus bars on the earth and the neutral connections, and just all the large amounts of copper wire and soldering in there, and it's just done so well, eh? But yeah, so but the point being is we've got individual switches. I might next year get a cheap Chinese power board that's got switches, so it's just smaller and lighter, but this will do the job. No worries there, of course. So I've got exactly the same lighting rig as last year. This small CFL, which we'll use as the master bedroom light, and this small LED light which we'll put in the boys' room on this skinny little cable, which probably isn't mains rated, but it hasn't blown up yet. And this one here, this 5 watt, I don't know, something LED light. It's kind of warm, can hold it though. That's kind of like the living area lamp, and that's also the one we take on the Beltane missions, because it's got a US plug on it which we can plug into the Wii self-powered inverter that Stormhammer gave us. And this LED bulb naturally will run off 230 or 120, so yeah. So that's pretty much it. That's my setup. Oh, this battery here is not part of it. This arrived today by the courier. Same courier as yesterday, so we started having a bit of a chat. This is the one that I was originally bought to improve the battery situation in the B shed, but what I've decided to do is install this in the A shed on the A bank, because it's basically the same size and shape as the batteries in there, same brand too, same rating, but just different connections. It's got studs instead of flag terminals, but that's alright, I can deal with that. Annoyingly, it got supplied without the blimmin' stud screws in there. That's a bit of a cunt, but we'll deal with that. So yeah, and then I can take it. There's a 100 amp hour battery on the A bank, one of those sort of long skinny ones, which would be better suited in the B shed. So we're doing a bit of swapperoo there, but that'll be not just yet. So that's basically it. There's the solar panel, like I say, 20 watt semi-flexible mono crystalline panel. And finally, oh, the pump. Yeah, let's give that a bit of a demo. Plug it in, and this must be plugged into the direct outputs. If you plug it into the others, it'll cut in and out as the protection activates, and I'm not going to demo that. I'll just show you that in the right outlet it works. Oh, that's nice. That's really nice. It's so hot here today. It's unreal, even though there's no sun at the moment. Oh, there we go, stay. Right, yeah, I whipped off the original cigarette lighter plug and just put this DC coaxial plug on there. So it just plugs straight in, you know, no hassles. Oh, one more thing I made. This, because the Power Buddy inverter we used last year had a built-in, just a small LED work light, not a very amazingly bright light, but it was just kind of useful to leave on while we were away from the tent, so it wasn't using much juice, but it kind of lit up our tent so we could sort of see where it was in the dark, because this place we're going to is pretty damn dark. So I just made up this. It's just a T5 wedge lamp, LED lamp that Owen gave me, and I've just soldered it on and used a bit of sheath off an old TPS cable to make a sort of a covering. So it's just like a mini powered torch really. Just bung it in there. You know, it'll look better at night, of course, but you know, it's pretty bright to look at. But it's just to give this little tiny bit of background illumination without using much juice. See how long it lasts for, who knows. See, so there we go. That's day 380 off the grid, and now I'm going to go and whip the case back on my thing, and probably pretty much soon cancel this soak test. Basically, I'm just testing that the inverter is hacking the loads of the lamps, but you know, it should do. There's only about 12 or 13 watts worth of lamps running here, but you know, that's all I really want. But there's a spare outlet. Baffy can charge her tablet if she takes it or whatever. This is certainly not for bringing all the comforts of home along to camp and plugging in, because yeah, I don't really believe in that. I know I look like a hypocrite with all this equipment here, but you know, I like equipment and I like solar and I like taking the solar camping. And it's just when you got kids, it's nice to have some really decent solid household style lighting going on in your tent. It just makes life a lot easier. And also with the band, you know, and the stuff we've got to set up, it means we can also use it as a place to get dressed or tune up or whatever with some decent lighting, not relying on camping lanterns or torches all the time. So there we go, day 380, and that'll do.